So, welcome everyone. First of all, a very happy International RSC Day. This is the third year where we are celebrating International RSC Day. It started in 2021. So it's not like a fixed date, but they do celebrate it on the second Thursday of the month of October. So in 2021, it was, I guess, 14th October, and now today it's the 10th. So thank you so much for taking time out, joining this discussion. It's very important for us to reach out to people on the ground, talk to them about research software, how they're using research software in their work. So I'll briefly introduce myself. I'm Saranjeet. I'm the co-founder of the Research Software Engineering Asia Association. Um, Jyoti, who's also on this call, is my co-founder. We started this organization or this community on the very first International RSC Day. So it's like a very special day for us as well. It's our 3-year launch anniversary. Um, so as a part of this community, we try to conduct community calls and raise awareness in our region. Um, so far, we haven't really planned a huge series like this one. So this is the first time we are doing like a 6-month series and giving people an opportunity to interact with people who work in with research code. This is the very first episode, enabling open science through research code. And we thought for this episode, we'll keep it lightweight, try to talk with people who are using code and research, doing research in real life. So that's where we are. It's going to be a lightweight conversation. So with that, I'll hand it over to Anelda to briefly introduce herself.
Thank you very much, Saranjeet. Good morning, afternoon, or evening to everyone. Thank you so much for taking the time to join us today, as Saranjeet was saying, on International RSE Day. And the word RSE or the term RSE might not be all that familiar to everyone. And that's why we're also launching this series as a conversation with researchers who code and talking about research software and research coding. And hopefully throughout the series, you'll learn more. You will also share more about the work that you are doing so that we can also grow more awareness of the amazing research software work that is being done on continents of Asia and Africa. So I'm Anelda van Walt, a bioinformatician by background. 20 years ago, as part of my master's degree, I found myself developing software for research purposes on the African continent. These days, I run a South African-based company, Talarify, which is dedicated to providing training and support for data-intensive and computational research. I'm a strong advocate for open science and for the democratization of scientific knowledge, and work across the global north and global south to promote these principles and to provide opportunities for cross conversations and sharing resources and opportunities. As such, Talarify has been supporting the research software and systems community of Africa, also known as RSSE Africa, which was founded by one of our colleagues who is in the audience today, Peter van Houston. And for the past year and a half, we've also worked with the Research Software Alliance as an African community engagement partner. And you'll learn more about these different organizations through the shared resources document that we've put on the chat. And we'll also publish that on our website. So I briefly wanted to introduce the concept of talking about open science and research software. You might be surprised about the theme of this conversation series. I think because open science is most often associated with open access publications. And we've got Joe Hoffman in the room, who's very involved in Africa Archive and other initiatives around open access. Or open data. And there's also some people in the room who is more engaged in research data management, open data, and so forth. But as research becomes increasingly digital, software is at the heart of modern scientific innovation, and we wanted to use this opportunity to highlight the critical role of research software in enabling research in general and open science in particular. So in November 2021, the UNESCO adopted the Open Science Recommendations to foster more accessible, transparent, and inclusive science. And these recommendations were unanimously adopted by 193 UNESCO member states. You can read more about those recommendations, about the development of the recommendations, as well as the implementation and monitoring on the UNESCO Open Science web pages. The framework covers open access, open data, citizen engagement, but one of the key pillars are also open research software, which comes as a surprise to people because, as I say, the traditional open science movement has focused a lot on publications and data. So research software are the software tools, software that underpins everything from data analysis, simulation, AI modeling, and ensuring it's open and accessible is really critical to reproducibility, which has become a very key conversation topic in research, collaboration, and specifically interdisciplinary collaboration, and trust in scientific outputs. So when we talk about open research software, we are referring to tools, algorithms, and code that are used in scientific research, but that are also produced in scientific research for research purposes that are openly available for others to use, to modify, and to contribute to. And there are definitions of research software, which we can also refer to in our resources document. And the reason why we're also talking about research software when we're talking about open science is about enabling transparency and making sure that the tools we use to produce scientific knowledge are as open as the knowledge itself, as I referred again to publications and the data. And this helps to ensure that research is reproducible and trustworthy. So one of the questions that we often run into is, why is open research software so crucial to the future of science? And it can be summarized by pointing to reproducibility, collaboration, efficiency, and innovation. Of course, there are challenges to open research software that we need to address, and that's also the reason why we are hosting conversations like that, and why we are hosting conversations as opposed to presentations or expert talks. The place where we're in at the moment, the time and the situation really lends itself to getting feedback and getting input from the broadest possible stakeholders, because we are busy shaping what does research software looks like, what does open science look like. And the more input we get from the people in the room, and the more we ensure that there are more people in the room to have these conversations, the better it is for everyone. So some of the challenges that we run into when we're looking at research software is infrastructure and maintenance. Often there are funding available to develop software, but not necessarily for maintaining the software, and the same for infrastructure. You can buy a new HPC, but who's going to look after it in 2, 3, 4, 5, 10 years' time? Training. Not all researchers have the necessary skills to contribute to, or even to use or to develop open source software. So there's a huge need for training and capacity development. And in our events that we've run in the past, we also always come across this need by our community members. And then big one, recognition. There are a lot of people who are spending a lot of their time developing software, but this is not yet getting the same recognition as publishing papers. And the challenge there is that people who are spending more time developing software often find their careers are jeopardized because they can't show that they are contributing to scientific knowledge and to the outputs that are measured by traditional research systems. So this is also something that we look at in our respective communities, and we can share a lot of information about that as well. So I look forward to hearing the thoughts and experiences of our speakers and my co-facilitator, Saranjeet, today. And throughout the series of discussions, and hope that we can further advance open research software and the people who develop and maintain it, to make it a cornerstone of open, inclusive, and sustainable science. And with that, I hope that you have a better context of why we're talking about open science and research software in one breath. And I would like to hand back to Saranjeet.
Thanks a lot, Anelda. That was a huge deep dive into why we are hosting these events and also emphasizing that this is more of a conversation, not a expert talk or a presentation session. So let's keep that spirit intact. With that, I'll want our speakers to introduce themselves. We'll be going alphabetically, so Biandri, Gaurav, Mahmood, and then Prasad. To help you have some pointers to talk about, I'll be sharing a few questions in the chat. So you might want to refer to those questions, or if you don't want to, then feel free to lead the conversation as you feel suitable. So with that, Biandri.
Thank you very much. Good morning, everyone. It's nice to be with you this morning. So I'm Biandri Uber, and I am based in Johannesburg at the University of Witwatersrand, or Wits, in the School of Law. So I am a postdoc there at the moment, and I suppose I'm one of the people who use code in research that Anelda and Saranjeet asked to speak today. What I use it for, we'll probably get to in a bit more detail, but I think it's safe to say that it is probably one of the more surprising fields as you know, for someone to use code in. But anyway, long story short, I have a postgrad qualification in law, and I'm specifically in international trade law and the health measures that either allow you to import and export plants, insects, meat, animals, that type of thing, or not. So that's the short summary of what I do. I know there are more questions coming, so I won't dive any deeper into how I use code or why exactly.
Thanks, Viandri. I'm very interested to hear your perspective coming from law background and how you apply code in your work. Next up is Gaurav.
Yeah. Hello, everyone, and thank you very much, organizers, for having me here. I am Gaurav Bhalerao. I am a postdoctoral researcher at the Clinical Neurosciences Department in University of Oxford. My background is interdisciplinary, so I am actually electronics and telecommunications engineer in my bachelor's, and then I did my master's in biomedical engineering. And then I did my PhD in National Institute of Mental Health and Neurosciences, NIMHANS, India. And now I am as a postdoctoral researcher working here at the University of Oxford. So in this role, I work in the neuroimaging field, which involves acquiring and analyzing brain MRI scans from clinical and research population. So more specifically, I work on developing tools, workflows, and pipelines to analyze large-scale data sets, which can help in early diagnosis and determining the treatment response for psychiatric disorders. So definitely this involves lots and lots of coding, and I would love to share more in the upcoming session. Thank you.
Thanks, Gaurav. It sounds like you have a very interesting career path and your journey through your degrees. Next up, Mahmood.
Hello, everyone. My name is Mahmoud Abdurazak. I'm from Egypt and currently work in UCL. I have a bit of a varied background. So started in geology, did some policy and governance and administration, finance, and government work, did mining, and then moved to data. So I do now work as a senior research data consultant in the Advanced Research Computing Center in UCL. And my role mainly involves helping researchers to build data pipelines or database systems for the research. Thank you.
Thanks, Mahmood. Would love to hear how your perspectives from your role in the government, policymaking, and also in code. So our last speaker, Prasad.
Hello, everyone. I have done my bachelor's in mechanical engineering, and then I did my master's in robotics from University of Bristol in UK. While I was transitioning between these two degrees, I was also briefly working in the private sector. I worked with a mechanical engineering company with Volkswagen, and then I worked with Infosys, a software company, which is where I got an insight of working in the field of robotics. Recently, 1 year back, I joined University of Bristol as a research software engineer. and there I'm working in Department of Chemistry. In Department of Chemistry, I'm mainly focused on atmospheric chemistry, and in the coming session, I would like to speak more about it also. Thank you.
Thank you, Prasad. It's interesting to see how you've moved from chemistry, like robotics, to chemistry. So yeah, looking forward to hear more about it. I'll hand over to Anelda. She has some polls to share with the audience.
Wow, this is absolutely fascinating. And I think your respective stories are probably quite encouraging as well. Often we find that researchers seem to have this very clear trajectory of moving within a discipline and within academia across the career, the ladders, the steps of the ladder. And we often find ourselves a little bit worried if we are moving across disciplines or moving between industry, academia, government even. But it's really fascinating to hear that all of you have quite distinct stories. And I hope that we can capture some of that stories and also share that with our audience in other ways and hear from our audience what their respective stories is. So we have a few questions that we'd like to share with you, and I hope the technology will allow us to capture your responses. In the audience, we would love to hear from you. How much of your working time do you spend coding? And it's absolutely fine if you don't code yet. There are options of none. I'm still learning to code, a few days per year, a few days per month, a few days per week, or most of my time. We're also asking you, what is your preferred programming language? So for those of you who are coding or would like to learn to code, what would you like to learn to code in, or what is your preferred programming language or languages? Doesn't have to be only one. Then the last question we're asking is, because we don't have much context of our audience, in which discipline do you work or study?
Okay, so like this is the main part that we have been waiting for, the panel discussion. So what we will be doing is we'll be sharing a group of questions with our panelists. Again, the first group of questions is for Gaurav and Mahmood. It's about what do you do in your typical workday, how much time you spend coding, what kind of projects you work on. Do you work in a team? Is it like a collaborative work? So those kind of questions, your typical work day. And I'll drop the questions for you in case you want to refer to them. But yeah, so does any one of you want to start this, Gaurav or Mahmood? This is just for the both of you, but Biandri and Prasad, you could also add to it if you think there's something that you wanted to include in the chat. Yeah.
Right, so my day varies because in my position, it's a little bit different. It depends, what I'm saying, a little bit different from the other RSE groups across the UK. The UCL group is quite large, so that means we are able to specialize towards specific things. What I do mainly is data management or research data in general, and my day depends on if I'm working on a project, as in I'm building a project or delivering a project, or if I'm developing a project. So if it's the developing stage, it will be more conversation and collecting requirements, talking to researchers, making sure that we have the correct design for the problem that we're trying to solve. If it's delivering, it would be more towards either writing some code or reviewing someone else's code, or maybe having a meeting with a team of a project to steer where we're heading with the maybe development direction. I would say about maybe 2-3 days of the week, I'd spend at least 3 hours writing code. This is a rough estimate, but and it depends also, like when you say code, what do you mean? Because a lot of the tools I use are not really programming. They're maybe like I don't know if you consider Terraform or Ansible to be programming. They're not really programming language, at least not in the sense of like Turing complete programming language. But they are writing some code. Yeah, that's, I guess, Have you developed software that used by others? Yes.
So like, is it like, are your end users the researchers, or are your end users anybody in the open source community?
Okay, well, so there is this and there is that. So I'm not a maintainer of a specific package, but I have participated in developing some of these packages. And the other side of this is that quite a few of the services we provide are used by researchers and end users. Sometimes it would be using packages that already are there, in addition to some of the code that we write to bash them all together in one place. And some of it is just we rewrite our own services.
Okay. So, and as a software person working with researchers, when for example, when you start on a new project, and you're gathering requirements from the researchers, are there any specific challenges that you face in terms of the language of communication? Is it easy to talk to researchers? Do you think, I mean, do you take any measures to ensure that they get used to your way of working as a software person, like the research development cycle of a software product?
I guess I'm a bit lucky because my background starts initially outside software, so I can see what people who do not write code specifically would be seeing in a project. For example, it wouldn't make much sense for a researcher why adding one particular feature that for them seems to be quite hard takes a day, while another one that seems easier would take maybe a couple of months, but for us would maybe require changing some of the design. So I guess because of that background, because coming from outside resource software engineering or software engineering in general, it's a bit easier for me to see eye to eye with the researcher and anticipate these kind of questions and maybe answer them ahead of time and explaining things. The other thing is, as you mentioned, or as I mentioned also, I did work in the government before, and one of the tasks I had to do is to make sure that a piece of legislation is understandable or possible to comprehensible by all levels of the community. We're talking about people who are investors, but they don't know how to read and write, so illiterate investors, all the way to international investors who would like to see this piece of legislation in multiple languages. So I have some experience in being able to adjust my level of communication to the level of the audience, which makes it a bit easier for me.
Mm-hmm. I see Biandri has just pointed out uh, how she works with in her doctoral research. Let's also check with Gaurav. What does your typical workday look like?
Yeah, I think before saying how my workday looks like, I would like to share one personal experience. And I am an engineer who never liked coding. I was afraid and scared of coding, especially during my master's. I went to a friend of mine who is a very good programmer, and I'm like, I have this brilliant idea, but can you code it for me? And then literally he coded in front of me, and I was just telling the logic of things. And it was such a scary experience that I never touched any programming language. But then when I started my PhD, I was in the hospital setup where I told like I work on analyzing brain MRI data sets, and I had lots of expert clinicians around me who were doing research, and then everyone was like, "Oh, you are an engineer. You can make this task easy for us, right? Because we want to copy these many files, we want to rename these many files." And I'm like, "Okay, now I have to code because I am an engineer, the only engineer," and that was the time it hit me that coding is necessary, especially when I had like 1,000 brain MRI images in front of me and I had to rename them. I'm like, I can't sit and rename it like because these are big data sets that I want to analyze. And that is the moment when I started exploring things, and I loved it so much. And now I come to the question, like, how much time I spend on coding. I code daily. It's like something, even though like in my day now, my role is more of a evolving as a supervisor and a guide role, but still I would love to code. If I don't code, I'm at this stage that, I cannot sleep. I'm like, okay, I need to code something, related to my work, or do some statistical analysis using R, or, something that I learn in the coding, because a lot of things in my field are evolving in such a way that, coding is absolutely necessary if you want to explore your own ideas. So, uh, that's something that I try to do daily. Sometimes it is not possible, but still, like, at least half an hour I try to sit and, learn something new about any programming language. About the projects, yeah, there are multiple projects that we handle. Some projects that I lead, some projects that I assist master students or PhD scholars in our department, and it's great. Like, even working with clinicians earlier, I really enjoyed later when I learned things. I really enjoyed making certain tasks automated for them, because they're extremely busy into their clinical duties, and when they want to do some research and I do something automated for them, they are extremely happy. And I think that happiness was something that gave me the boost to learn more and more, and to make these tasks easy for people who are expert in something else and still want to, use such kinds of things in their field. uh, right now, my current work focuses on developing harmonization of data, which is acquired on different MRI machines, so that we can pull multiple data sets together from different studies and increase the statistical power in neuroimaging analysis. So this definitely involves lots of different programming languages. And in neuroimaging field, it's like different groups develop different softwares in different languages, and then if you want to test it out, then you need to know the language, you need to know the syntax. So basically, I don't say that I'm expert in any programming language, but I would say I can read those programming languages, and I can, troubleshoot, and I can test out different tools on my data sets and see how things work out. Thank you.
Thanks for sharing your journey, Gaurav, like from being intimidated by code to being to start loving writing code and seeing the value that people gain out of having automated tasks. Uh, so as you shared, you definitely have end users or people who use the work that or the software that you develop. So is while working on these projects, do you have others as well, like someone from your team who helps you write the code, or is it you as an individual working on those projects?
Yeah, I think most of the times I write the code, and then the best way that I do is I give that code to multiple different people to test out and see whether it is fine, and it is doing the task, and it is not doing something. Sometimes it's like when a code runs, and if there is error, I am happy. If it runs without any error, I'm like, okay, what's wrong in it? Because then you have to look very closely at what is happening in the code. So yeah, most of the times I write the codes, but I share them with the people, and uh, but then in neuroimaging, when there are other tools that are getting developed, so I always keep track of these tools and these papers, and then I'm always happy to test out their codes on my data sets, and sometimes raise issues on GitHub, or tell them that it's wonderful. So yeah.
So like you mentioned you used to interact with people in hospital settings, and they used to give you feedback on what they want from you, or what you're doing, whether it's working for them or not. So what kind of tools did you use when gathering these requirements? Did you like use some notes, or were you using things like GitHub issues? How were you tracking all the requirements that were coming to you?
Yeah, it's a good question, actually. It was bit of a informal, like, I started using version control tools just when I started my, like, in the last year of my PhD, but that was just to maintain my own codes. But for the clinicians who had specific requirements, yes, we would discuss, and then whenever I would develop a piece of software or something for them, I would write SOP for that, which is again a good exercise for me. Like, okay, what I have done, and then these steps of procedure, like how their data should be organized to kind of, use a particular code or tool. So, and then how should they give the input and what they might expect, what errors they might get, how can they troubleshoot on their own. So I would write these SOPs for them. And that has been a good exercise for me also. And it's like, even if now I leave a particular institution, that SOP stays, and then they can still refer to it, and they can still troubleshoot or work on those things.
Yeah, that's a very good suggestion of writing a SOP. You have a question from the audience. They're asking, do you get requests like using a particular language or tool for programming or creating the data structure from your end users? Do they insist that you use a particular tool or a language?
Yeah, it it again depends. Like, I have my own preference, so sometimes I write in those languages. But yes, some people definitely prefer, for example, like Bash, because it's easy to manipulate files and everything. So yes, sometimes I get the requirements, and I try to adhere. If I really don't know the language at all, and still they say, okay, I want this in this particular language or something, then maybe I tell, okay, I might need time to think. But definitely, like, I'm not promoting AI tools, but definitely there are certain AI tools now where you can translate your code, and then you can test out different things. So definitely for testing purposes, I use these tools. For example, converting a Python code to MATLAB or MATLAB code to Python. And I check these things, whether it is really working, whether it makes sense, whether it is doing the same task. So all these things apply. But yeah, definitely it's a great experience.
Thanks, Gaurav. Over to you, Anelda.
So let's move on to the next set of questions. We're going to pose these to Biandri and to Prasad. And this is more about, I think in the preparation for this session, we had a quick meeting with our panelists, and we were asking them if there's anything specific that they would like to share with us. And as you've already noticed, Biandri is from a humanities social sciences background. And we wanted to highlight the fact that coding is pervasive across all disciplines, and specifically hearing about opportunities and challenges in the humanities social sciences. So this is perhaps your opportunity, Biandri, to tell us a little bit more about, as someone coming from law and the humanities faculty, what how did you get into coding, especially in an organization or in a discipline that isn't known for coding? And how many other people do you know in your department or faculty that code? Are you building a bit of a community there? Are you finding your tribe, or do you have to mostly work with people in other disciplines? And then we will chat a little bit with Prasad about that as well.
Awesome. Anelda, how I got into coding, actually Benito is on this call today. He was part of the problem. I messaged him one day and said I need to draw nice graphs and tables for work that I was doing with trade statistics in my PhD. What was that coding thing you were talking about recently? And that's kind of where he started. He pointed me in the direction of carpentries, and during COVID, I got in touch with someone for some private tutoring on R, and really that's where it started, and it's developed to the point where I use it quite a lot for content analysis of legislation. So I work with text mainly, but I do also work with import and export statistics, so volumes and values. So it's not particularly complicated, but more recently looking at trade flows using different R packages, that type of thing. But yeah, text is my primary medium that I work with. And your question about community, that type of thing, there isn't a large community of people that code in law. In fact, in my organization, I don't know anyone that codes, in the School of Law at least. There are a lot of people interested in coding, but like from a distance. So a lot of people are interested, but on actually doing it. So I am trying to encourage some training, that kind of thing, or for people to get involved in the same way I did. I've never formally been taught how to code, in the sense that it wasn't through university module or anything like that. In fact, none of my learning was related to any of the universities at which I studied my master's or my PhD. But yeah, so it developed out of necessity during my PhD that I Excel had kind of reached the point that it could help me with the visualizations I was doing. And so it happened to fall into my, or at least into my knowledge of it at the time when I had both time, but I also had a project to work towards and to apply it to. So I think that's very important. The communities I'm part of are mostly online communities. So communities such as this, the OLS community, our ladies, Slack channel, that type of thing. And really, I learn a lot from different disciplines. I think that has been a great advantage, not having a large legal coding group or legal coding community, is I have been forced to learn from other disciplines, and other disciplines are doing really cool stuff that are entirely applicable in law. And it's really continues igniting my passion for encouraging people with legal backgrounds to get involved in coding, and not to see it as something that you need a strong statistical background in. You don't just have to use it for stats. It's great if you do learn stats, or if you have an application for it as well, but very little law or legal arguments are based just on the law. We've got data about climate change, we've got data about the environment, we've got data about trade, the rights of the child, you name it. There's data in that is applicable in a legal field. So yeah, I did see on the screenshot earlier of the fields people are in. I unfortunately don't see anyone in law on the call, but if you know someone, send them in my direction. I would love to encourage them to get involved in coding and to see that it's possible. I think the main message from me is I didn't do this from undergrad. I started this in my PhD. That's only about 4 years ago that I started it. And I am very glad I did. I'm very glad that I continue to learn.
Thanks so much. There's a question about easy, accessible resources for learning to program, and we can perhaps move that question to the next section where we're going to talk about training. But I'd love to hear from Prasad as well. Prasad, in your organization, how many people code? How do you find people that code? And are you a bit of a community, or is most of your community outside of your organization? How do things work for you?
Yeah, in my case, my organization is an academic organization, so there are already a lot of sessions that are going around coding. But in terms of research software engineers in my organization, it is more than 25 now, and we have some new joiners in the past few months, so I think it has touched around 30. What we tend to do as a group in our organization is that we conduct various training sessions for the PhD students and new joiners who might have to interact with the code in their research work. Apart from that, in our organization, it is an embedded RSE structure. So all of us are embedded within the particular research groups. So there also, depending on the size of RSEs, we try to have more focused or personalized sessions for that particular group as well in terms of coding. So one such example can be in atmospheric chemistry, the data that we get is in terms of netcdf formats. So researchers over there need to like they want to have an idea about how they can easily gather that data, clean it, try to get some visualization out of it, or run it through some machine learning uh, logic, which can help them get more insights. So these kinds of questions we get, and we try to have some training sessions around them, provide them some tutorial. So that's how we work in our organization. Yeah.
I have perhaps a controversial question that connects to what we're talking about. And for all of our panelists and also for the audience, do you think all researchers should program?
In like I would just like to say this, like in for this particular question, is that uh, it's good that researchers have some idea about the code, because what I have felt in my experience while I was teaching them is that there are some minor cases where it is not essential that an RSE needs to directly start working on it or create some huge system out of it. But there are the minor cases like someone just needs to download the data from an archive and just run some mathematical operations like do mean, mode, median, and get some visualizations out of that. So we already have some minimalistic functions that are provided by various packages. So in that case, they feel very helpful that that process is enabled for them. Although all of this stuff can be done using Excel, but like I said, the data format changes, and that is somewhat restrictive for them. So I found like having an idea about code and uh, they know how to write some basic code is always helpful, is what I felt.
Thank you so much. From our other panelists, Kaur, Mahmoud, what are your thoughts?
Yeah, I think means in my opinion, it's more like even if you cannot code or you don't want to write code, but at least it would be really helpful if you can read the code, because sometimes in my field, like a lot of things are already developed or available, or the experts who are really good at coding, they develop the software, but then how that fits to your data or how that fits to your purpose, for that, you need to learn to read the code. And even if you cannot write, it's fine. But if you read it, if you can read it, then you can better troubleshoot it and you can better see where the problem is. Then you can go to the expert saying, okay, this is where the problem is. Otherwise, what happens is when you are not able to read the code, then you don't know what is the problem. And then it takes a lot of time to kind of narrow down the problem by the developer sometimes, because they don't know what is happening and how your data is and what you are exactly doing. So this basically comes from my experience where I stayed most of my time in a part of India where the local language was different from my language, and I learned to read the language. So I could not speak, but I could read it, and that was very helpful for me. And from that, I kind of learned that even if you can read the language, that would be helpful for you, even if you cannot write it. That's completely fine.
Thank you. That's a very interesting point. I see some comments in the chat. Is there anyone else who would like to say something on the question of whether all researchers should be able to code, be able to read code?
There is a very interesting comment by Yusuf Mortara. If you want to unmute Yusuf, they're talking about everyone should know about the first aid at least. So
Yeah, I can maybe add a little bit more about that. So I mean, you know, the comment stands, but the big thing that comes in is making larger systems. So when you're making larger systems, you need some ability to determine whether it's correct or not. Because computers are just a great way of making mistakes really, really quickly, you know, millions of times quicker than your average human can make them. So, you know, there you start to get into issues of design, modularity, stuff like that. And you know, what was originally sort of maybe 4 programs that you kind of string together and they're scripts and it's cool. You know, by the time it gets to 7 that are strung together, wow, now the relationships are complex, everything's fragile in between, nobody dares to touch this, and sometimes things go wrong. Nobody knows why, but if it gives a particular error message, contact this guy at this email address, and he will, you know, a hell of a lot of, I see Anelda just like nodding over there, yeah, a lot of, you know, kind of software kind of ends like that, which doesn't mean it's not useful, but what I always query is when software is like that, and you know, I mean, people still use it and it's still useful, but my question to those people is always, well, if you're using it and you don't know why there are errors happening, but you know that errors happen sometimes, how do you know errors aren't happening that you don't know about? I mean, how are you actually checking the correctness? In which case, you know, and there have been some quite famous cases about. I think there was one a few years ago about MRI imaging, where the standard software for it was just recoloring some area, and so you know, something like 8 years of research just basically had to be redone if you happened to use that particular, which is kind of your ridiculous. Um, but people trust the machine too much. As a computer scientist, we don't trust it, we suspect it, and it's that, you know, that when it gets larger is very difficult. So I think everyone should code, but I mean, if my arm is broken, I don't try and put on a bandage myself. You know, I go to a doctor. So you've got to kind of realize when it grows beyond the limits, and you're going, well, okay, let me actually just bring someone in.
Some very valuable points you're making there. I see Mahmood and Bianri also have their hands up. Mahmood?
I think one thing that we need to be cautious of is that skills outside formal education translate to time. What that means is that if a researcher wants to learn how to code, they need to take this time out of something else. And the reality is that a lot of the researchers wouldn't do that, regardless of we want them to learn or not. It's just they might not actually have the time to do it. And I'm cautious a little bit of I'm going to translate the question that you asked into a different question, which is that do you prefer to have no code whatsoever or badly written code? Because the reality is that programming, like any skill, takes time to learn, and if you don't dedicate time to it, you end up producing something that is maybe not the best solution for the problem you're facing. And if you've been with universities long enough, there is this infamous term that people use called researcher code, which is sort of analogous to spaghetti code, which not really great, but just to understand that there are limitations that are imposed by the researcher being able to write their own program. One of them is obviously the language that they use. So sometimes you get a project and they would want to use specifically Python because they've learned Python, but maybe it's a high performance thing and it requires something like Rust or C++, but they're not able to do it. So you're limited. And also acceptability of that particular language within the domain. And then the second thing is in terms of the, I don't know if you're familiar with the Dunning-Kruger effect, which is that if you've learned, okay, so that is sometimes is a problem. So there's a follow-up from Yusuf's point to know when it's too deep for you is a skill by itself and is not very easy, is not given to learn. So just people to be cautious that sometimes this happens, and we always face it in our lives, regardless if we notice it or not. We always all are subject to this in the skills that we learn. So I'm not saying researchers shouldn't learn how to code. I think they should, but I think we also should be realistic in our expectations. Okay.
Thanks so much. Very, very valid points, and tying nicely there to what Yusuf was saying. Bianri.
So I also don't have like a yes or no answer to that particular question. I think yes, and I'm come from a legal lens now. So if you are working in fields of regulating any code-related technology or whatever it might be, at least understanding, that like introduction to R or Python level of coding allows you, as Gaurav said, to at least have an idea of what the language looks like. So when I say yes, people should learn to code, I don't mean learn to code on the levels that I think most of the other panelists code on. I mean, learn to code on a level where at least you have had some sort of interaction with it. You can do a couple of basic analyses, that kind of thing. I also think it makes understanding your data more relatable if you can actually code, because I've had experience in the past trying to help someone visualize their data, but because they come from a background such as myself, where we aren't accustomed to working with data in any form other than texts, and then quite limited to doctrinal analysis, it takes quite a bit longer to try and understand what the message is or what the value is of this usually qualitative data that has been captured. So I would say, but also, as Mahmoud said, it has to be in a university context for there to be time for it, because I do see how once you leave that university context or, educational context, whatever it might be, it becomes very time consuming. And like you say, time is something that most people outside of formal education do not have to learn this type of thing. So at least introductory, sessions, that type of thing, but relatable, because learning coding when you come from a text-based background and you're learning with, penguin data, that kind of thing, is very unrelatable. So it takes longer. So there are ways, I think, to make it take less time. But I think an entirely good idea to get as many people coding, but also, and this is my final point on this, to get people to believe that they can code. So whether or not they do or don't is then their choice, but that they can. So again, drawing from my background, I studied law. I see now that you don't have to be good at math necessarily to code. The code does the math for you, but you've got to understand what you're trying to do or how you're trying to get there. And I think there's a very big misunderstanding in backgrounds such as myself that coding is equal to you had to be like top in your class in math or something like that. Whereas it's a language, or I see it much more as a language, like Gaurav said. And for me, when I made that mind shift of I'm learning a language, the little bit of Python I have experience with now, it's just another language. It's not, and people with my background are typically quite good at words and languages and that kind of thing. So learning the different terms or the syntax is not beyond the realm of possibility, even if you're not big into stats or machine learning or whatever other things people are doing with it.
Thank you so much. I've kind of stolen some time from the next section, which really leads us nicely into learning to code. How do you learn to code? And I'm going to hand this over back to Saranjeet.
Yes, I think so while we are discussing about how to learn, it's a very relevant question. Where do the speakers of our panel today get their training and support from? If you want to share any communities that communities of practice that you found helpful, or I think Beandri did share a few communities earlier. So if there are any communities that you would recommend the audience to join, and any trainings that have had a specific impact on your current career, please do share about those. We are again going in the same order. Beandri, let's go with you first.
Okay, so the communities of practice that I have been part of, it also goes in waves. I'm not always very active in these communities. Are the Our Ladies, OLS, Anelda has a very nice community kind of vibe in South Africa. So Anelda is my community, but so I've been in touch with a couple of South Africans, researchers and coders through Anelda, help me with the word. I've lost it. Escalator, sorry, the escalator, and that type of thing. And what training has had an impact on my current career? Well, very much just learning the basics of R, and then with practice and my own input, working out how to apply that. But it's just repetition really has had the biggest impact. Repetition and struggling through the problems. I'm very glad I learned how to code in the time when ChatGPT didn't exist. So I was forced to learn how to work with problems and how to read code and understand what I was doing wrong and what might be wrong, rather than referring. I'm not saying don't use tools that exist to help you code now, but I'm just saying I think that time and effort was the biggest impact on my current use of code. And my career isn't as a coder, my career is as a researcher in international trade law. But I think the coding impact has enabled me to make conclusions and to work with data that I could not work with otherwise.
Thanks, Viandri. Gaurav, did you want to go next?
Yeah, sure. So I think I am mostly a self-taught programmer, and but then eventually when I started exploring more things and I started having more and more issues in my coding, you realize that there are certain patterns that you should not follow when you're coding, and that is the time when I started reaching out, attending some seminars, workshops, and but these are brief. Like I never got any formal certification or anything, because most of the times in my field things are developed in any programming language, and so I just have to be adaptable to everything. And like I said earlier, I just should be able to read the code and test the code. Maybe if there are different softwares, I should be able to kind of see how they reproduce the results and if that makes sense. But I would definitely suggest that the carpentries community have been really, really effective for me. So recently I became a certified carpentries instructor, and then I thought that this could be the more formal and formal way to kind of help others. But I would definitely say that by helping others, I mean, actually I helped myself a lot. Like when people get issues in their coding, actually you kind of learn quite a lot that how you should code, so that your code should be accessible and generalizable to everyone from beginner to the advanced level. So I would definitely say from my experience, I would say that carpentries communities is good. So if anybody would like to get involved, maybe attend carpentries lessons. The lessons are available online and they're so easy to learn. Actually, they're very well structured and everything. So what I did was I became helper initially before becoming the instructor. So when I became helper, then in the carpentries workshop, you can actually help people who are getting different issues. So that kind of made my circle really, really nice. So yeah, that's what I can say.
Thanks, Gaurav. I really like the comment, by helping others, you are helping yourself. Mahmood, did you want to go next?
Yeah, sure. I think my advice would not be, I think people already talked about communities, so I'm gonna touch upon this from a different angle. My advice would be to, if you're in the beginning of your journey to learn how to program, try as many different venues as possible. Try as within programming is not just one thing. You could do, maybe people usually classify to back end, front end, and stuff similar to this, but there are a lot to programming than maybe Python and R, and you wouldn't know which one you feel better fit in unless you try it. So give yourself a chance to try multiple things before you settle on one particular domain. And a good way to do this exactly, as Gaurav said, is to help others. So if you go on GitHub and search for a good first issue, you will see a list of issues that people have tagged with this particular tag. And these are usually open source projects that you can try to contribute to. I'd say if it's your absolute first issue, then try documents first, try documentation first, and then aim for code after this. And the most important advice is that try to make mistakes a lot, because you're only going to learn by mistakes. If you're afraid to make mistakes, you're not going to learn anything.
I
Thank you.
love that comment about try to make mistakes and and learn from those mistakes. I also liked your point about uh, looking for multiple ways, starting with multiple platforms and figure out which one works for you. The point about good first issues is also a good entry point for anybody who wants to explore more about how to contribute to open source. So I guess those are really, really good advices. Um, Prasad.
So yeah, I would just like to add to the point that Mahmood said, which was related to learn to do mistakes. So in coding, it's more like you learn coding when you actually do some mistakes, you get into the errors and you try to understand those errors. So that is the part where I've always felt like I've learned so much about the way I should write the code or way that particular code was performing. And if I would like to say about my journey where I got the training for my coding is that when I was working with Volkswagen, which was a mechanical based company. So there I was working on lots of like Excel sheets which contain huge data, and I always used to wonder like it's taking almost half a day every day just going through that data and trying to understand what's wrong in it. So I used to speak with my colleagues over there, and the technical director of that particular uh, company pointed me towards Python, and he said like, why don't you try doing something with Python? And I said like, okay, that's a good suggestion, and but I don't know anything about coding. So he just said that he just pointed me in a direction, and I then started to just when I used to go back from my company to my house, I used to open my phone and just look at the online resources. And like Gaurav mentioned previously, I used to read through that particular code, read through that page, and I just used to try and understand what that page is saying. And that is how I first started to understand what the code is doing. Then when I got more time on the weekends, I then started going through actually writing some code, learning the syntaxes and all of that. So it was more about like Gaurav and Mahmood said, you should at least try to understand what's written over there, read through it, and then once you get on with writing the code, you should try and get into more and more errors and try to see more and more red lines on your on your screens, and that is where you would you should actually start learning. And I'm just going to share some resources that I found helpful along my journey. And those are very free, so please feel free to go through them also. Yeah, thank you.
Thanks, Prasad. Really nice comment that don't be afraid of those red lines on your screens. Try to read what the error message says, and also be open to your colleagues. Talk to your colleagues. They might have resources that they can point you to, and if someone is ahead, you feel someone is ahead in that journey, you talk to them and get a starting point for yourself. Uh, there is one actually question for all the speakers. What is the most significant pain point you had when learning to code? So I think this is for everyone.
So maybe we can take two responses. Who would like to respond? What has been the most significant pain point in learning? Saranjeet, what has been the most significant pain point for you as you have been learning to code? You're a research software engineer.
Yeah, so I have a degree in statistics, so I come from a background which was very heavily and focused on R. So everyone that I knew when I was doing my graduation was very familiar with R, and I didn't face a lot of challenges when talking to them. But then I did an internship after my like around my MPhil degree, and I moved into a company. And over there, I found myself so alone because everybody else was talking Python, writing Python, and I had no clue what is happening. So I guess that mind shift from R to Python, I found that a bit challenging because although so R is more for people who don't come from a like a very technical, like a programming kind of background, and that was me. But Python is much more. So if someone is doing JavaScript, they can find Python more familiar. But if person like me, I found it challenging. So what used to happen is if I was given a problem during that internship and I was told to, write a code, I would start thinking in R. I would write the whole code in R, and then I would look for packages that could, and this was like pre-AI. So like there were packages that could transform R to like connect R to Python. And so that is what I was doing, like getting very deep into R instead of learning a new language. And then one day, like my manager was, why don't you just write this code in Python and bring it to me? If you have any error messages, we'll try to debug those error messages. So that day I was like literally sitting for hours, and I made sure that I'm transforming the whole code into Python. And that was the first uh, moment for me where I felt a bit more confident that I can learn or pick up another language. But it wasn't easy. It didn't come easily to me. I struggled. I still kept thinking in the language that I'm familiar with. But yeah, I needed that push and that support, I feel. Yeah.
That's probably something that's quite relatable to people. I first learned Bull, which is a language that we shan't speak about. Yeah, I think most people will not count that as something that researchers should learn today. And then having to learn Python and R was for me also quite a challenge. Is there any final comments before we wrap up? Are there any final comments from our speakers? Gaurav, anything you would like to add to the conversation?
Yeah, I completely agree with Saranjeet's point that even for me, it's like for her, it is like R to Python. For me, it is like MATLAB to Python. And I am a huge MATLAB fan, and still I haven't left MATLAB because, I love it, though it's not open source and everything. But I think during my academics, MATLAB was the only tool which we used to use for signal processing and image processing and everything. So it is kind of we say like a mother tongue or something, like we say, it's the native language. But then slowly I moved on. uh, Not the significant pain, but I would say pain is daily. It's like, every day you are learning, and every day you are going to face issues. The only thing is, and like rightly pointed out earlier, don't be afraid of those red colored messages, and just try to look into them, try to see maybe you can solve it. And rather than just saying, I've seen some people directly saying, oh, the code is not working. I'm like, okay, it's not working, but just try to look into it and try to see if you can add something or remove something to make it run. If you can do that, you can search online, and thanks to all the resources now that we have on the internet, you can get lots of information. You can put the issue, you can talk to people online, and you can sort the things out. So I would say that it's a daily pain. Like whenever each day I decide I want to code something tomorrow, I'm always like, I don't know whether it will get, I will code it up in a day or in an hour fully, because I might face errors. But then always open to learning new things and opportunities, I guess.
I would just like to add to this is that uh, the pain in learning to code is that finding time and to start to learn the code. Because once you learn any language, you kind of develop a transferable skill, which is to which is basically understanding the basics of the fundamentals of that fundamentals of coding, I would just say. And once that is done, you just have, it's more about learning new syntaxes, and that can be done easily. So find some time and start with any language that you feel is more easy to understand. Python is usually preferred, but I would say just find some time for it and you would be done with learning coding.
Bianca, any final words for the audience?
No, just start if you haven't. Because if I could, with a legal background and very little relatable databases, learn it, then I think any background really can find a way to learn how to code and find value in it. That's the most important thing. I see there's some comments about in the chat about like what language to start with, and I agree. It depends on what you want to use it for, but more importantly, at least in my experience, it depends on what you have access to for training, and whether or not you can afford paid or whether you would require free training. So in my case, I used a lot of open source resources to learn, and that worked best for me.
Thanks, that's very valuable. And I think also what language is being used in your discipline mostly. Often the languages are or disciplines prefer languages, or labs prefer languages. So find out what is being used in your community and then try and team up with others. So don't, like, always best not to try and do it alone. Find your tribe. So it's 12 o'clock on my watch. It's time for us to wrap up. I really want to thank our speakers for your contributions, for being so easy and flexible, and sharing your honest journeys as researchers who code, and picking up from people like Biandri, who is a dedicated researcher who also codes to enable her research, to some of our other panelists who are working as research software engineers who engineer code that are being used in their disciplines or even beyond their disciplines and contributing to open source. As we'll see throughout the rest of the series, there are a wide variety of roles in the landscape of research software. And we're hoping to provide some useful content and resources to people across this range of roles. So thank you, Saranjeet, as well, for helping to come up with a plan for the series. For Jati and Mireille, who's been in the background helping us with capturing questions and resources onto our shared document. We will go through all the chats and make sure that all the questions are answered, as I mentioned in the beginning, either in the document or shared with you via an email and perhaps a blog post. And then I am very excited to share with you the registration link for our next conversation, which will have some different speakers. And we're going to look specifically at enabling reproducibility with your code. How can you make sure that your code can enable reproducibility in your research projects? What can you look at? What small changes can you make? What new skills can you learn? And looking at some more technologically advanced options as well. So with that, thank you very much. We hope to see you in upcoming sessions. Please feel free to share these opportunities also within your communities. The next few sessions will be more focused on skills that will be relatable to people who are already coding, but that doesn't mean that everyone isn't welcome. Anyone is welcome. We'll try and make it as accessible as possible, but also making sure that people who are already in the world of research software can benefit from participating in our series. So thank you very much. Enjoy the rest of your International Research Software Engineering Day. And we look forward to seeing you again.
Thank you.